During the next couple of minutes, you're going to learn how easy it is to estimate power consumption on the nRF9160 system in package using the online power profiler tool for LTE. You're also going to learn how to measure the actual power consumption using the new power profiler kit too. We have seen from our customers' feedback and people working in the cellular IoT space that it can be very difficult to estimate power consumption. That's why we have developed this online power profiler for LTE to make it easy to estimate power consumption. This online power profiler tool is actually located on our webpage, DevZone. So if you go to the developer zone, you can find the online power profiler tool on the front page, located here, or you can go to Nordic content and select the online power profiler tool from here. So on the main page we have the well-known online power profiler tool for 52, but we are going to look into this new one for LTE. So as you can see, this is very many parameters, network parameters that you can add into your calculations. So to make it easier for customers, we have these presets already on the page. So you can select, for example, a network that you know, and you can set up a scenario. Let's just go through all the different parameters here. So here you can select the nRF9160 revisions. So we are selecting the latest revision because it has improved power consumption numbers. And you can select the network mode, either NB-IoT or LTM. And you can select if you're going to use PSM mode, if you want that in your estimate. The interval for the PSM, the periodic tracking area update in seconds. So this is set to 3600 seconds, which is 1 hour. And you can also select the active time, which is the RRC idle time. Since in our case, we are going to showcase only the power saving mode, we turn off this. Then we can see that the active mode disappears. And for our demonstration, we are going to enable data transfers. So we enable upload and we select 10. This is because we are going to showcase the UDP sample in the nRF Connect SDK, which is our software development kit. And in that sample, the default upload transfer interval is 900 seconds, which is also 15 minutes. So each 15 minutes it will send 10 bytes data up to the cloud. And you can also select the output power. We select 23 dBm, which is max. And for the inactivity timer, we have selected 4 because on the network I already chose that. In the presets, I'm on this network in Norway, so it have already selected all these parameters for me. Let me also show you how you can do that from the measurements later on. And you can also select the clock stop current for the SIM card. For example, the iBasis SIM card has around 30 microamps as the clock stop current. And you can also disable GPS if you want that in your measurements. When you have all this, you can see that the calculations have been done on the top here. You can see that the total average current is calculated to be around 83 microamps. And the PSM floor current for the revision 2 of the nRF9160 is 2.7. And this has been simulated here. You can see go into each event. First, we can see the network sync. It's estimated to have a charge around 1.2 millicoulomb. And we can also see the SIM synchronization, which it has to be done before the network attach. And here we have the RRC setup and the reconfiguration. And we can see that you have the tracking area update. And we also see the data upload, which you can see we send 10 bytes. We can see the charge, which this calculator has estimated this. So here we have the DRX inactivity timer. We can see after that we go into cDRX idle, cDRX event, cDRX idle, cDRX event until we get this final RC release from the network. And then we have this last inactivity timer, and we go directly into PSM mode. What's very nice with this calculator is that you can actually export these settings and also import settings. This is for the network parameters. So if you have found out some different network parameters that is not in the presets, you can export these settings after you have configured it. And you can also import those settings later on. And from these parameters you have set here, for example, you have set send 1000 bytes. We can export the NCS, NRF Connect SDK project config. And then we will get this opp.com file, which we can add on into our UDP sample to get the same exact parameters to send the data, for example. So we can set up different scenarios. However, in our example, we use the default one to showcase the UDP sample when you build it out of the box. And we can see that it's 83 micrograms. I also recommend to check out the user guide on how this online power profiler works and how it's set up and the different modes in the LTE space. What is important to note in the online power profiler is that this tool has been based on the actual measurements using a CMW 500 radio communication tester. This means that the estimates are most likely a little lower than the actual current consumption on a real network, because this CMV 500 radio communication tester does not include different noises that can come on the real network. When it comes to actually measuring the current consumption on the nRF9160 system in package, you can use our new Power Profiler Kit 2 and use the compliant Power Profiler application in our NRF Connect for desktop. On the nRF9160 development kit, we are going to run the UDP sample from our NRF Connect SDK. So let us look into the UDP sample in the NRF Connect SDK. We are now in NRF Samples nRF9160 UDP. And we have selected the kconfig files to see what the default parameters are. So you can see that the UDP data upload size in bytes are 10, as mentioned earlier, as well as 900. That's why we have selected 10 bytes and 900 seconds for upload frequency in the online power profiler. And in the project conf file, we can see that we are also running on LTM network and have selected the periodic tau, and also we have no active timer. So we go directly into PSM mode. And we have not used eDRX. You can of course test this on your own if you want, compare with the online power profiler. So now you open up the terminal, for example, if you're using Visual Studio Code, and you can run the west command, west build B, selecting the board, nRF9160DK, and selecting the non-secure zone, and then we select the build folder. And we also add in the flash command, west flash, and select the build folder. You run this, and this will flash the nRF9160 DK. If you want to learn more about the UDP sample, please go to our NRF Connect SDK documentation page and select the application and samples section, and samples nRF9160 UDP. Here we cover most about the UDP sample and the dependencies of this sample. A small note for the documentation page is that it's recommended to select your NRF Connect SDK version at the top here to have the correlating documentation for your version that you have downloaded. 1499 means that I am running the latest documentation page, which is from the NRF Connect SDK master branch. So let's say I'm using NRF Connect SDK 1.4.2. Then I will use this documentation version. But for the sake of this demonstration, I will just keep using the latest version. I also highly recommend to check out the application development site where we have this power optimization guide. So this power optimization guide covers more or less the same things and more of the things that's covered in this video. When it comes on how you can set up the Power Profile Kit, you can go to Info Center and select NRF Tools and select the Power Profile Kit 2, and then you can see how you can set up the Power Profile Kit in different modes. So here you can see how I have connected the PPK2 to the NRF 9160. I have the brown V-out connected to the VDD NRF on the NRF 9160 and the ground connected to the minus on the external supply. So let us open the Power Profiler tool. It's in NRF Connect for desktop. This software supports PPK1 and PPK2. So we have the PPK2, so we select that device. Now we are connected. We can switch between source meter and ampere meter. This will also change the LED color on the device itself. We use the supply voltage 3.7 volts or 3700 millivolts. And we can also change the sampling rate of this software, which means that we can record the waveform for a much longer time than before. So now we can sample the device for days if we want to. And you also have this new real-time feature. You can have the trigger type, single, continuous, and also you can change the trigger parameter. This is similar to what you've seen in the older version of the Power Profiler software. But we are going to use the data logger in this demonstration. So we select the sample rate. Since we are sending data each 15 minutes, we will just sample over that time, so we can make sure to catch that. And then we start sampling. Enable power output, and we can see that the NRF 9160 turns on and runs the UDP sample. I like to lock the E-axis and also hide the log, so we can get a better view of the whole waveform. You see that it records in the background through that little animation there. In the meantime, we can just play around with the waveform and zoom in and zoom out and look at the different measurements. So we can see that the power saving mode average current is around 2.8 microamps in this case. So let us look at the waveform. So if you don't know your network parameters in the online Power Profiler tool, you can run this UDP sample, and also then you can zoom in and see the different parameters from the network you're on. So from the waveform we can find out the different network parameters that we have in the online Power Profiler. We can see the RC inactivity timer in light blue, cDRX interval in orange, cDRX on duration in dark blue, and cDRX inactivity timer in green. So we can zoom into the waveform and look at the different timings for the different events, and then put those network parameters in the online Power Profiler. So let us try to find out the cDRX interval, for example. We can do that checking between two cDRX events. And it should be around 320. Yeah, that's correct, 320 milliseconds. So we put that in the cDRX interval on the OPP. And the next parameter, we're going to look into cDRX on duration. And this we can see on the event here. So it should be around 40 milliseconds. Perfect. So we put that in the OPP. The next parameter we're going to look at is the cDRX inactivity timer. It can be seen in the end here, right after the RC release. It should be around 300 milliseconds. So we put that in the OPP as well. And the last one is the RC inactivity timer, which you can see from this spike to this last spike. It should be around 4 seconds, and as we can see it's 4.1, so we can put that as 4 in the calculator. So then we can export those settings in the online power profiler tool, so we have those saved for later. So you can play around with those network settings. So now we're going to let this measure for around 19 minutes, and we're going to come back to this tool. So here you can see I open up previously saved waveform that I've recorded for over 20 minutes. So here we can see the timeline delta. It's around 15 minutes here, and we go from after the network attach to the next event after 15 minutes. So we can actually see that the average current is 86 microamperes. From the estimation of the online power profiler tool, we can see that we get very similar numbers. So we can see that we get 83 microamps from the online power profiler tool and 86 microamps from the actual current measurements for the 15 minutes time interval of sending the data. So now we will learn how easy it is to estimate power consumption on the nRF9160 using the online power profiler tool, and also how you actually can measure the real current on a real network to see a more accurately average current consumption. So this information can be used to then again calculate the battery life of your application. And you can set up different scenarios and see what different parameters can affect the power consumption. If you want to learn more about our nRF91 series, please visit nordicsemi.com cellular IoT. And if you have any technical questions, please visit our Nordic Developer Zone and get in touch with our tech support.